Hey everyone, I'm Bianca Nicole Santos and welcome to my channel. Today, we're diving into a really cool experiment that compares the egg membrane to a salmon brain, exploring the concept of semi-permeability. Hope you enjoyed this video. Here's what you'll need. 2 raw eggs, vinegar, corn syrup, water, an old spoon, food coloring, and clear jars. Make sure to gather all your materials before starting. First, let's wash our eggs. Then put them in a clear glass container. Then put vinegar to completely submerge the eggs. This is where the magic begins. Now, let's set the egg for 48 to 72 hours. I'll be back in 24 hours.
24 hours later. Twenty-four hours later.
eggs were submerged in vinegar, you probably noticed bubbles forming on the surface of the eggs. This happens because of the acidic acid in vinegar reacts with the calcium carbonate that makes up the eggshell. The reaction produces carbon dioxide gas, which forms those bubbles you saw. Over time, as the eggshell dissolves, what's left behind is the egg membrane, which remains intact. This membrane acts similarly to a cell membrane in living organisms. It's flexible and semi-permeable, meaning it can allow certain substances to pass through while blocking others. After submerging egg in corn syrup, you probably noticed that it shrunk in size. This is because corn syrup is a highly concentrated solution of sugar, which has less water than the inside of the egg. Water moves out of the egg through the semi-permeable membrane to balance the concentration of water between the inside of the egg and the surrounding syrup. This process is called osmosis. The water flows from an area of higher concentration inside the egg to an area of a low concentration to reach equilibrium. On the other hand, egg B, which was submerged in water, swelled in size. In this case, the water outside the egg had a lower solute concentration compared to the inside of the egg. Water entered the egg through osmosis, causing it to expand. This shows how the movement of water across the membrane works in different solutions. Yes, when we change the submerging liquids of the eggs, their sizes change, but in different ways. Let me explain. Egg A, after being transferred from corn syrup to water, slightly increased in size, right? This is because after being in a hypertonic solution or the corn syrup, the egg had lost water. So, when placed in water, it began to absorb it again. The water entered the egg through osmosis to balance the concentration gradient, causing the egg to expand slightly. Egg B, however, remained roughly the same size when transferred from water to corn syrup. This is likely because the egg had already absorbed as much water as possible while submerged in the water, reaching its maximum size. Once placed in the corn syrup, osmosis is still occurred, but the effect was less noticeable since the egg membrane had already expanded. Over a longer period, we might expect egg B to begin losing water. But within the short observation window, the size change is minimal. The egg membrane in this experiment served as an excellent model for a cell membrane. Like a real cell membrane, the egg membrane is semi-permeable, which means it allows certain substances to pass through it while blocking others. In this case, water molecules move through the membrane in response to the concentrations of the surrounding solution, mimicking how cells regulate their internal environments. See you next time!